Hello students. In the last week we have seen some basic concept required for quantum mechanics, and we had a quiz or assignment on that concepts. So I will discuss all the questions because some of you have given very good answers, very correct answers. Some of you have a little bit confused, so I'm going to explain all the questions and what they actually mean, what they are asking for, so that you will answer carefully from the next assignment. So the first question is, the photoelectric effect can be explained using dash dash aspect of light. So the first question is, the photoelectric effect can be explained using dash dash aspect of light. So what we have to choose here is which aspect of light is required to explain the photoelectric effect. We have two aspects of light. One is particle and other is wave. So we have options wave and particle. So particle is the correct option and wave is incorrect option. Almost all students have selected particle, but few are few have selected wave. So the correct nature required to explain this effect is particle nature of the light. We can use aspect or nature. Both words can be used here for wave as well as particle. So why we will discuss this a little bit. We have already a video on our channel Thrust of Curiosity. Go to the interesting quantum, in the playlist of interesting quantum we have that video, 8 number video, photoelectric effect. So you can discuss, you can see basic theory there, but I will discuss one more point in that. So why particle and why not wave nature? So the basic thing in the particle nature is the number of photons is proportional to the intensity, or intensity is proportional to the number of photons or number of light particles. So we are call photon to the light particle. So number of particles of light means number of photons. If number of photons will increase, intensity will be increased of the light. This is particle nature. But in case of wave nature, we relate the intensity with respect to amplitude of the wave, and this intensity is related to the energy of the wave. But what observed in photoelectric effect was, as the intensity of light increases, we can increase the intensity of light. So still we suppose we don't know whether light is particle or wave, but what we can observe, the effect we can observe. So what was observed in photoelectric effect, as we increase the intensity of the light, incident light, the energy is not increased but current is increased. Small I is representing the current. So capital I is intensity, small I is the current. So current increases means what it can related to. So it is number of electrons flowing per unit charge. So electron is a discrete unit of charge. So we can relate every electron with every photon. So the particle nature can be explained. But what happens if we increase the intensity, energy of the outcoming electrons, photoelectrons we call them, that will not increase. So this fails, wave theory fails to explain the photoelectric effect. So we require particle nature. There is one more reason why wave theory cannot explain the photoelectric effect, and that is delay. So what wave theory suggests, suppose this is a metal surface and suppose this wave is incident on the surface. So it will take some time to capture the photon and then it will emit the electron, not actually photon, because in wave theory it is called wave. So it will take some time to capture the wave, and then it will take time to eject one electron. Okay, so this delay is not found in practical. So when experiment was done, so they found instantaneous emission of photoelectrons. So that is also the reason why we cannot explain photoelectric effect on the basis of wave theory. That's why we need particle nature of the light. So that is the reason behind this. Okay, so this is all of interference is only explained using wave nature of the light, that is property of wave to having interference pattern. So no need to explain this. Okay, the wave function is basic concept in quantum mechanics. Can we use it in classical mechanics? So in this question, few of you, almost 9 of you have given answer yes, and 5 of you have given no. So I feel we should discuss this in more detail, but already I have made a video on this concept. Okay, so in this we have introduction to quantum mechanics. In this we have discussed how quantum mechanics is different from classical mechanics. Some points are discussed in this video, and if you go back and in this same channel, Thrust of Curiosity, there is one playlist called Nanophysics. Go to that playlist, and there is one concept, there is one video, is classical physics wrong at quantum level? So watch both videos. So basically what we have discussed in those videos, so in principle we can use quantum ideas in classical mechanics, but what happens if I assign a wave function to a moving car, then it is very small that we cannot detect it or we cannot study it. That's why usually in classical mechanics we ignore, we do not study the wave function, but still we can use. It is not prohibited, it is not discarded in classical mechanics. It is just neglected because it's small size, very small size. We cannot detect it, we cannot study it classically, but quantum mechanically we can study. So we found it, and then we can relate it to classical mechanics. We can use it, but no one will ask you to use because it is so tiny effect is there in classical world. But still there are some books in which for mathematical purpose they will give some problems. So suppose find the quantum number of a moving planet, so you can even relate to the planets, what will be the quantum number. So those quantum numbers are tending to infinity. So as number is tending to infinity, we have studied basic structure of energy levels. So suppose here is for hydrogen atom n equal to 1. Okay, so this is energy level, first energy level, and then as we go on increasing, as n increases, the difference between two energy level decreases, right? So as we go to n equal to infinity, so as we go to infinity, this band gap or this gap between two energy level is so very thin that we cannot detect it, we cannot find it. So what we assume in classical mechanics, that this is continuous spectrum, or what we call as continuous function. So what happens, there is already very small gap, but what happens, we cannot find it out because n is so high, and we know E is inversely proportional to n square, right? Another aspect is we have already discussed in that video, that lambda, that is the wavelength of such particle, moving particle, is h upon p. Even we suppose that velocity is very less, still mass of a car is very greater compared to this h. This h is Planck constant, which is of order of 10 raised to minus 34. So this is very small number. So whatever the wavelength comes out is very very small, and that's why we neglect this concept in classical mechanics. But still we can use it, we can have calculations on it, but we don't use it because it is no need to use it, but we can use it. So the question was, can we use? So they are not asking whether we use it or not, they are asking can we use, so we can use. So that was the answer. Most number of people have marked this answer as wrong, so that's why I elaborated this more. Then this answer has everyone given correct. Wave does not transfer matter, but it transfers the energy. So we all know that. Which properties of light can be explained using either of two aspects of light, that is wave aspect and particle aspect? So what here the question means is either of two. Here we have not used either or. So what here means is either of two means both. That is mean both properties can explain the property of light. So what is the ideal answer is reflection and another is refraction. So both these phenomena can be explained using particle nature as well as wave nature of light. So particle nature for reflection is simple. So like a ball comes, hit the wall and then goes back. So particle nature can explain well. Wave nature also explain well. It hits the wall and then it changes the phase and then it moves to the another direction. So this also can be explained on this particle nature and wave nature. Reflection can be explained. Then there is refraction. Suppose here is N1, that is refractive index of material 1 and refractive index of material 2. So I have taken this in general. So N1 and 2 can be different. It can be air water, air glass or water glass, any two media. So the wave can be bent. So this can be explained using particle nature as well as wave nature. So in wave nature the electric component is affected due to the property of that medium, and in particle nature also we can explain this in terms of resistance, but classically it sometimes get difficult to explain refraction, but we can explain reflection. But both these phenomena can be explained. Even we can explain the rectilinear propagation of light. So what rectilinear propagation is? So it always follows straight line path. So what if we say this is wave, so this will not travel in wave, I mean in straight line. So how we can defend this, that it can both be particle as well as wave? So the thing is, straight line, if there is some wave and we have seen this from very far distance, how will it look? So it will almost look like a straight line. So that is the same case. So how far we are looking? So if this is wavelength, okay, so this much is wave. So for this much portion, the light is almost same in same direction it is going, it is straight line. But if I saw only this term, so now I can see the wave nature. So it still exists in both forms. So these three phenomena, reflection, refraction and rectilinear propagation of light, these three phenomena could be explained on the basis of both particle as well as wave nature. So that was the question. We have to name any two properties of light, like reflection, refraction, which can be explained on both using both the concept of or both the aspects of the light. So most of you have given correct answer, reflection and refraction. Yeah, okay. So some of you might have confused. So they have written electromagnetic wave and photon. So these are two aspects of light, right? You are right, these are names of wave and particle, but we have asked which properties of light can be explained using this two, wave and photon nature or particle nature. So that is the question, and correct answer should be reflection, refraction and rectilinear propagation. Then the next question was, which properties of light only explain particle nature of light? So or we can say which properties of light can be explained using particle nature of light. That was the basically question. So this question also answered correctly, almost all of you. So photoelectric effect, as we discussed earlier, so you have to write any two. So this person will not get full marks, he will get 1 mark, he or she, that student will get 1 mark because written just one answer. But this is correct answer, photoelectric effect is correct, Raman effect is correct. So there is some spelling mistake, so this is the correct way to write Raman, because he is a scientist. So don't write first letter small, write first letter capital, because Raman is name of scientist. You can write P here in small if you have written it second, but you should always write Raman as a first letter capital, R should be capital. So Compton effect is also one phenomena which can be only explained using the particle nature or particle aspect of the light. Then there is black body radiation, that can also some of you, okay, polarization and diffraction are completely different and they can only be explained using wave theory or wave nature. So this person will also get 1 mark only. Yeah, these three correct, but R should be capital. Yeah, photoelectric effect, Raman effect and Compton effect. Compton is also name of scientist, so C also should be capital. Okay, these are general properties, so this is not the question means, so this person will get 0 mark. So yeah, so basically we have to discuss some phenomena or some properties of light which can be explained using particle nature or particle aspect. Then similarly we have to find out the phenomena which can be explained using wave nature. So interference, diffraction, polarization are the correct answers. Some of you have written very good. So here also two correct answers will give 2 marks, otherwise one correct answer will give 1 mark. Even if you have written 3 correct, then also you will get 2 marks. Okay, then next question was, what is the threshold frequency in photoelectric effect? So here basically you can write the definition or you can explain it in a little bit your own words. So that was the idea. So some of you have tried in very different ways, some of you tried very good. So we will see what is the definition. So it is the minimum frequency of light or radiation required for an electron to eject from the metal surface. So this is the ideal definition. So even if you have not written correct, I mean in this sequence or in these words, then also you will get correct answers only if your concept is correct. I will explain why I am saying this. The minimum frequency of light required, so this is correct, this is correct. Minimum frequency of light which required electron to eject from metal surface, correct. Okay, here someone has used radiation, that is also correct. Light is alternatively used as radiation, so that is correct. That will produce a photoelectric effect, that word is also fine, so you can use, you can get 2 marks here. A minimum amount of frequency required to eject an electron on a metal surface is called threshold frequency. Yeah, this is also correct definition, you can say this. Okay, you should not say amount of frequency, you should just say the minimum frequency required. So this will also get 2 marks actually. Okay, here what I mean, it is defined a minimum frequency of incident radiation below which photoelectric emission is not possible. This was complete. You should not write completely. So this does not mean anything here. So up to not possible is the correct answer. So that will give 2 marks. So it is defined as the minimum frequency of incident radiation below which the photoelectric emission is not possible. So you should not use completely. In photoelectric effect, after bombarding of photons on metal plate at certain frequency, it starts emitting electrons, and before that no electron or energy is emitted. Okay, so you should not use or energy, because light is energy, and if it reflects, then we can say that it is emitted, because it might be captured by electron and then released. So you should not say energy, but you can say before that no electron is emitted. One more technical thing here should be, instead of before, you can use below. Why? Because if I'm moving from higher frequency to lower frequency, so what this will mean, even if we decrease the frequency, then also photoelectric effect is possible. So that is not the correct answer. So either you can write below that, or one more way is to write you are moving from lower frequency region to higher frequency region, then you can use before. So I will give 1.5 mark. So this will not give 2 mark, because there are some technical mistakes here. Okay, here also that is a description of the threshold frequency, but this does not explain anything. Is the frequency at which effect is barely possible. So this is incomplete definition, because this is right, it is barely possible, but it is here in this definition we should write it is not possible below that. Below word is important here, because after that, so this definition also do not say what after, if I am going at this below of the frequency or above the frequency. So this does not tell anything, both the definition. So this will also get almost 1 mark just. Okay, this is also fine. Incident radiation below which it is not possible. Okay, someone has written this number. I don't know how this number has come from. So this might be in case of some material, some metal, but this is not in general same for all metals. Metal to metal, this frequency changes, the reverse voltage also changes. You will know what is the reverse voltage if you watch that photoelectric effect video. So there is no in general frequency as such. You might have searched on Google and you have got some number. So this number might correspond to some metal. So try to find out that metal. Okay. So this is not true for all the metals. So this is for some particular metal. It can be possible. Then we have the last question. State any 3 phenomena which cannot be explained on the basis of classical mechanics and requires quantum mechanics. So already in the last week we have discussed that photoelectric effect or wave particle duality. Wave particle duality can tell all the phenomena like photoelectric effect, Compton effect, Raman effect, which describe particle nature, and polarization, diffraction, interference, which explain wave nature. Both can be explained on wave particle duality, so which cannot be explained on classical level. Classically we cannot say this is wave as well as particle. That's why such we need to state such 3 phenomena or such events or such properties. So basically I proposed 4 ideal equation, but you can also add this was that 4 properties or phenomena, wave particle duality, which also explain photoelectric effect, Raman effect. So those answers are also correct if you have written that specific. Ultraviolet catastrophe, that also we have discussed in the last week. Hyperfine structure, that also discussed, and electron spin, which was not discussed completely, which is yet to be discussed in upcoming video. but still this was the correct answer. So many of you have written these four answers exactly in the same order. I don't know how you have approached these four answers. Some of you have written some different answer than this, and that was uncertainty principle, so that is good attempt. All those who have written three correct answers, they will get 3 marks. Otherwise number of, so this will get 2. This will actually you have written ultraviolet, just it should be ultraviolet catastrophe, but still you might get 1.5. This will get 2 marks, this will get 2 marks, and half mark for this. I will tell 5. So what here means is, in this question, state any 3 phenomena which can be explained on the basis of, can't be explained on the basis of classical mechanics. So probability is not the thing which cannot explain classically. We can explain probability. So what is probability? It is a classical concept, but what is additional in quantum mechanics is the probabilistic nature of particles. So probability is different thing, actually it comes under quantum mechanics, but we can explain probability. So you might have seen my video in which I stated that classical mechanics plus uncertainty plus probability is quantum mechanics, but that probability is not as such probability, so I will give half mark for that probability, but it should be ideally probabilistic nature of particle if you have to write that probability. But still good attempt, I would say. Then I don't know how this for, yeah, someone has given black body radiation, that also we cannot explain classically, so that also explain the particle nature and cannot explain using wave nature. Heisenberg uncertainty, Compton effect, photoelectric effect, these can also given. So I have clubbed these two in wave particle duality. So this answer is correct, you will get 3 answer. That might be some typing mistake, so I will ignore that. So if you are having some typing mistake, then that is okay, but if the mistake is conceptual, then you will not get that mark. Okay, so all these 10 questions we have discussed. Even if you have still any doubt, you can feel free to ask me, and thank you for watching. Have a happy learning.